Corrugated fiberboard is a paper-based material consisting of a fluted corrugated sheet and one or two flat linerboards. It is made on flute lamination machines, or corrugators, and is used in the manufacture of shipping containers and corrugated boxes. The corrugated medium and linerboard are made of kraft containerboard, a paperboard material usually over 0.01 inches thick. Corrugated fiberboard is sometimes called corrugated cardboard, although cardboard might be any heavy paper-pulp-based board. History: corrugated paper was patented in England in 1856, and used as a liner for tall hats, but corrugated boxboard was not patented and used as a shipping material until December 20, 1871. The patent was issued to Albert Jones of New York City for single-sided corrugated board. Jones used the corrugated board for wrapping bottles and glass lantern chimneys. The first machine for producing large quantities of corrugated board was built in 1874 by G. Smith, and in the same year Oliver Long improved upon Jones' design by inventing corrugated board with liner sheets on both sides, thereby inventing corrugated board as it came to be known in modern times. The Scottish-born Robert Guerin invented the pre-cut paperboard box in 1890. Euro flat pieces manufactured in bulk that folded into boxes. Guerin's invention came about as a result of an accident. He was a Brooklyn printer and paper bag maker during the 1870s, and one day, while he was printing an order of seed bags, a metal ruler normally used to crease bags shifted in position and cut them. Guerin discovered that by cutting and creasing in one operation he could make prefabricated paperboard boxes. Applying this idea to corrugated boxboard was a straightforward development when the material became available in the early 20th century. The corrugated box was initially used for packaging glass and pottery containers. Later, in the mid-1950s, the case enabled fruit and produce to be brought from the farm to the retailer without bruising, improving the return to the producers and opening up export markets. Manufacture of corrugated board. Corrugated board is manufactured on large high-precision machinery lines called corrugators, usually running at about 500 feet per minute or more. These machines, over time, have become very complex with the objective of avoiding some common problems in corrugated board production, such as warp and washboarding. The key raw material in corrugating is paper, different grades for each layer making up the corrugated box. Due to supply chain and scale considerations, paper is produced in separate plants called paper mills. Most corrugating plants keep an inventory of paper reels. In the classical corrugator, the paper is softened with high-pressure steam. After the board is formed it is dried in the so-called dry end. Here the newly formed corrugated board is heated from the bottom by hot plates. On the top, various pressures are applied by a load system on the belt. The corrugated medium is often 0.026 pounds per square foot basis weight in the US. In the UK, a 90 grams per square meter fluting paper is common. At the single phaser, it is heated, moistened, and formed into a fluted pattern on geared wheels. This is joined to a flat linerboard with a starch-based adhesive to form single-face board. At the double backer, a second flat linerboard is adhered to the other side of the fluted medium to form single-wall corrugated board. Linerboards are test liners or kraft paperboard. The liner may be bleached white, mottled white, colored, or pre-printed. Common flute sizes are A, B, C, E, and F, or microflute. The letter designation relates to the order that the flutes were invented, not the relative sizes. Flute size refers to the number of flutes per linear foot, although the actual flute dimensions for different corrugator manufacturers may vary slightly. Measuring the number of flutes per linear foot is a more reliable method of identifying flute size than measuring board thickness, which can vary due to manufacturing conditions. The most common flute size in corrugated boxes is C flute. Standard U.S. corrugated flutes, corrugated fiberboard can be specified by the construction, flute size, burr strength, edge crush strength, flat crush, basis weights of components, surface treatments and coatings, etc. TAPPI and ASTM test methods for these are standardized. The choice of corrugated medium, flute size, combining adhesive, and linerboards can be varied to engineer a corrugated board with specific properties to match a wide variety of potential uses. Double and triple wall corrugated board is also produced for high stacking strength and puncture resistance. Most corrugators are two-knife corrugators, which means that they can produce two different sheet lengths side by side. This leads to an optimization problem, known as the cutting stock problem. Box manufacture process, box design. Packaging engineers design corrugated boxes to meet the particular needs of the product being shipped, the hazards of the shipping environment and the needs of retailers and consumers. The most common box style is the regular slotted container. All flaps are the same length from the score to the edge. Typically, the major flaps meet in the middle and the minor flaps do not. The manufacturer's joint is most often joined with adhesive but may also be taped or stitched. The box is shipped flat to the packager who sets up the box, fills it, and closes it for shipment. Box closure may be by tape, adhesive, staples, strapping, etc. The size of a box can be measured for either internal or external dimensions. Boxes are usually specified and ordered by the internal dimensions. Box manufacturer's certificate, a seal printed on an outside surface, typically the bottom of the box, that includes some information about how strong the box is. This is also known as the box maker's certificate or box certificate. The certificate is not required, but if is used that implies compliance with regulations relating to the certificate. Significant information includes 1. Bursting test or edge crush test. 2. Size limit. 3. Gross weight limit. Manufacturing, boxes can be formed in the same plant as the corrugator. Such plants are known as integrated plants. Part of the scoring and cutting takes place in line on the corrugator. Alternatively, sheets of corrugated board may be sent to a different manufacturing facility for box fabrication. These are sometimes called sheet plants. The corrugated board is creased or scored to provide controlled bending of the board. Most often, slots are cut to provide flaps on the box. Scoring and slotting can also be accomplished by die cutting. Single-face laminate. A limitation of common corrugated material has been the difficulty in applying fine graphic print for informative and marketing purposes. The reasons for this stem from the fact that prefabricated corrugated sheets are relatively thick and spongy, compared to the thin and incompressible nature of solid fiber paper such as paperboard. Due to these characteristics of corrugated, it has been mainly printed using a flexographic process, which is by nature a coarse application with loose registration properties. A more recent development popular in usage is a hybrid product featuring the structural benefits of corrugated combined with the high graphics print of lithography previously restricted to paperboard folding cartons. This application, generally referred to as single-face laminate, begins its process as a traditional fluted medium adhered to a single linerboard, but in place of a second long fibered liner, a pre-printed sheet of paperboard such as SBS is laminated to the outer facing. The sheet can then be converted with the same processes used for other corrugated manufacturing into any desired form. Specialized equipment is necessary for the material construction of SFL, so users may expect to pay a premium for these products. However, this cost is often offset by the savings over a separate paperboard sleeve and the labor necessary to assemble the completed package. Recycling. Old corrugated containers are an excellent source of fiber for recycling. They can be compressed and baled for cost-effective transport. The baled boxes are put in a hydropulper, which is a large vat of warm water for cleaning and processing. The pulp slurry is then used to make new paper and fiber products. Mill and corrugator scrap, or broke, is the cleanest source for recycling. The high rates of post-consumer recycling reflect the efficiency of recycling mills to clean and process the incoming materials. Several technologies are available to sort, screen, filter, and chemically treat the recycled paper. Many extraneous materials are readily removed. Twine, strapping, etc. are removed from the hydropulper by a ragger. Metal straps and staples can be screened out or removed by a magnet. Film back pressure-sensitive tape stays intact, the PSA adhesive and the backing are both removed together. Materials which are more difficult to remove include wax coatings on corrugated boxes and stickies, soft rubbery particles which can clog the paper maker and contaminate the recycled paper. Stickies can originate from book bindings, hot melt adhesives, pressure-sensitive adhesives from paper labels, laminating adhesives of reinforced gum tapes, etc. Corrugated fiberboard shredders are now available which convert post-consumer corrugated board into packing cushioning materials by means of a specialized shredding process. Recycling corrugated fiberboards helps countries without sustainable wood resources build a paper and packaging industry locally. ASTM Standards, D 1974 Standard Practice for Methods of Closing, Sealing and Reinforcing Fiberboard Boxes, D 4727 Standard Specification for Corrugated and Solid Fiberboard Sheet Stock and Cut Shapes, D 5118 Standard Practice for Fabrication of Fiberboard Shipping Boxes, D 5168 Standard Practice for Fabrication and Closure of Triple Wall Corrugated Fiberboard Containers, D 5639 Standard Practice for Selection of Corrugated Fiberboard Materials and Box Construction based on Performance Requirements, D 6804 Standard Guide for Hand-Hold Designing Corrugated Boxes, and others. See also, box compression test, cardboard box, composition board, corrugated plastic, foam core, bulk box, paperboard, paper recycling, packaging and labeling, pasteboard, posterboard, edge crush test, references. Further reading, Fiber Box Handbook, Fiber Box Association, Gning, J. Corrugated Crossroads, a reference guide for the corrugated industry, TAPPI Press, 1995, ISBN 0-89852-299-4, European Corrugated Board Industry, Good Manufacturing Practices for Corrugated and Solid Board Packaging. This GMP standard allows packaging for the food industry to be made to the highest standards of consumer safety. All details at the website of the European Federation of Corrugated Board Manufacturers, Brody, A.L., and Marsh, K. S., Encyclopedia of Packaging Technology, John Wiley & Sons, 1997, ISBN 0-471-06397-5, Soroka, W., Fundamentals of Packaging Technology IOPP, 2002, ISBN 1-930268-25-4, Guide for Packaging for Small Parcel Shipments, 2005, IOPP, Asian Corrugated Carton Association, external links.